Okay, so looking at today's homework, we're working with functions. So we're going to be working through a function that is talking about a tree. As the tree grows, it grows 20 centimeters every year. So every single year, it is growing 20 centimeters. Now, so we need to be able to take that information and go through our process. So like for number 1, we need to write a function. For our function, it's always going to be in the format of y equals mx. Okay, so in our case, x is going to represent the number of years. M is going to represent the number of centimeters. So we know that with this tree that y equals, okay, every year it is growing 20 centimeters. And then we are going to put x to represent the number of years. So number 2, it says design or draw an input-output table and label the table. So we have one that started here, and we're going to use these ages. So our x's are talking about the age, the y is talking about the height. So when we're looking at this, when the age of the tree is 0, the height of the tree is 0 centimeters. When the age of the tree is 1 year, the height of the tree is 20 centimeters. When the height or the age of the tree is 6 years old, then the height of the tree is 120 centimeters. Now you're going to go ahead and finish up your table for when the tree is 10.5 years old, and then also when the tree is 20 years old. We've got the 20 from right here. We were looking at 240 months. That 240 divided by 12 gives you the 20, because it's 240 months divided by 12 months per year gives us 20 years. So now number 3, using the table from number 1, find the height of the tree for when the tree's ages are, and we have these 4 ages. Now we've already gotten started with that as we were filling in our table. So for when it's 1 year old, the way we figure that out is we're going to use our function to help us. So we do 20 times 1, and that gave us our 20 that we put over here in our table. Now, looking at B, when the tree is 6 years old, so 20 times 6, and that gave us 120 centimeters. And then you're going to go ahead and do C, and then also do D. For D, you're working with it when it is 20 years old to be able to find the height. All right, so now looking at number 4. So number 4, using the information gathered from number 3. So if you've already finished up your table, number 2 and number 3, you're actually coming up with the same information. Now label and graph your data. So we're going to take our information that we have up here in this table and bring it down and put it in the graph. Now, I've decided to label my axis by counting by hundreds for the y-axis. So the y-axis is measuring height, and so I counted by hundreds since I know that I'm going to end up having some big numbers with our graph. And then the x-axis dealing with age, so I counted by 2s. So going ahead and taking these numbers and graphing them. So we have 0, 0, so that's going to go right here. Then we have 120. Well, 1 will be right in the middle, and then 20 will end up being right about here. 6, 120. So 6, 120. Okay. Then you're going to go ahead and finish up with 10.5 and 20. Going ahead and graphing it. And then once you're done, you're going to connect your graph to be able to get your line. But you're going to need to go ahead and finish up your graph for number 4. Now looking at the flip side, thinking about that graph that you had in number 4, is the relationship between the years and the height of the tree a function? So you're either going to answer yes, it is a function, or no, it is not a function. And then explain. Remember that for it to be a function on a graph, there's 2 ways that we can think of it. When we're looking at information for a function, does each input have only one output? The other way to be able to look at this is if you are looking at a graph to do the vertical line test. So our question right here says specifically looking at the graph. So you're going to draw vertical lines or imaginary vertical lines across that graph. Does it touch the graph in only one place? Okay, so when you look at number 5, is it a function? Yes, it is a function because the vertical line only touches in one place at a time. Okay. Number 6, how tall will the tree be in 50 years? Thinking back to our function rule, we had y equals 20x, where x is the number of years, 20 is the height per year. Okay, so if we take that 50, then we're going to take that 50 and plug it in. And so that's going to mean that y equals 20 times 50, and that's going to let you know what the height is. So you can finish that math and figure out what the height of that tree is in 50 years. Now, number 7, predicting how many years until the tree reaches 1,400 centimeters. So again, we're using that function rule, y equals 20x. This time though, our 1,400, that's our total, that's the height that we're wanting to figure out. So we're going to plug it in, except this time we're going to plug it in for y. So that's going to give us 1,400 equals 20x. Now you have a one-step equation to solve to be able to find x, and x will be the number of years that it takes to be able to reach that height.